What if something older than our entire solar system just passed right by us, and most people didn't even notice? Not a planet, not a star, but a traveler from deep space that doesn't belong here at all. That's exactly what astronomers believe happened when 3I/Atlas entered our cosmic neighborhood. At first, it looked like just another icy object drifting through space. But the deeper scientists looked, the stranger it became. Its speed, its path, even its chemistry didn't match anything we've ever seen before. And this wasn't just unusual, it was unsettling. Because objects like this aren't supposed to carry secrets from a completely different part of the galaxy. Yet everything about it pointed to that possibility. As more data came in, researchers began to realize they weren't just observing a comet. They were looking at something far more ancient and far more mysterious than anything nearby. Now, new research suggests this object may have formed billions of years before our sun even existed. If that's true, then this isn't just a comet. It's a relic from a time when the galaxy itself was still taking shape. And what it's revealing is something no one expected.
It all started with a routine scan of the sky. Nothing unusual, just another night of automated observations. Then, suddenly, something appeared that didn't quite fit. The object was first spotted by the Atlas Survey Project, a system designed to catch potential threats heading toward Earth. At first glance, it looked like a typical comet. But within days, astronomers noticed something strange about its trajectory. It wasn't orbiting the sun like everything else we know, it was just passing through. That's when the realization hit. This wasn't a visitor from the outer edges of our solar system. It came from somewhere far beyond it. Only a handful of objects like this have ever been detected, including the mysterious Oumuamua that sparked global debate years earlier. But even compared to that, this new object stood out. Its speed was extreme, its path was unmistakable, and there was no chance it was gravitationally bound to our sun. Astronomers quickly gave it a name, 3I/Atlas, marking it as just the third known interstellar object ever discovered. But what seemed like a rare cosmic event was about to turn into something far more puzzling.
Once astronomers confirmed what it was, all eyes turned to where it was going. 3I/Atlas wasn't slowing down, and it wasn't sticking around. It was on a fast, one-way path straight through our solar system, swinging past Mars, slipping by Earth at a distance, and then heading directly toward the giant that dominates everything in its path, Jupiter. This was the moment scientists were watching closely. As it approached Jupiter, the question wasn't just where it came from, but whether its journey would be changed forever. The comet passed incredibly close on a cosmic scale, skimming near the boundary where Jupiter's gravity begins to take control. A slight shift here could alter its trajectory, maybe even fling it onto a completely new path through space. For a brief moment, this ancient traveler was caught in a gravitational tug-of-war between the sun and the largest planet in our system. But even that dramatic encounter wasn't the most surprising part of the story.
With its path mapped out, scientists tried to answer the biggest question of all.
Where did it actually come from? On paper, it sounds simple. Trace its trajectory backward and follow it home. But in reality, that's nearly impossible. Over millions or even billions of years, objects like 3I/Atlas are constantly nudged and pulled by stars, gravity fields, and unseen forces across the Milky Way. Those tiny changes add up, turning its past into a chaotic puzzle with no clear starting point. Some models suggest it may have come from the thin disk of the galaxy, while others point toward the older, more mysterious, thick disk. But none of those answers felt certain. So instead of focusing on where it traveled, scientists shifted their attention to something far more revealing: what it's made of. Using advanced instruments like the James Webb Space Telescope, they began analyzing the comet's chemical fingerprint, hoping it would tell a story its trajectory could not. And what they found would completely change the way we see this object. Then came the realization that changed everything. Based on its chemical signature, scientists now believe 3I/Atlas may be between 10 and 12 billion years old. To put that into perspective, our entire solar system is only about 4.6 billion years old. That means this object could have formed long before the sun even ignited, back when the Milky Way itself was still in its early stages of development. This isn't just rare, it's almost unimaginable. Objects from that era are incredibly difficult to study, especially ones that formed in completely different star systems and somehow survived billions of years drifting through interstellar space. And yet, here it is, passing right through our cosmic backyard, like a time capsule from a forgotten age. It has likely witnessed events we can barely comprehend: waves of star formation, violent cosmic collisions, and the gradual shaping of the galaxy as we know it today. Scientists now believe it may have originated during an intense period of early star formation, meaning it's not just old, it's a preserved fragment of an ancient planetary system that may not even exist anymore. And that raises a chilling possibility. How many other ancient objects like this are out there, drifting unseen through the darkness? Because if one managed to reach us, there could be countless more. And if that's true, then this comet isn't just telling us where it came from. It's revealing what the universe was like before we were even here to observe it.
And that's where this discovery starts to get even more intriguing. As scientists broke down the composition of 3I/Atlas, they found it contains many of the key elements linked to life: carbon, hydrogen, oxygen, nitrogen, and sulfur. These are the same building blocks found in living organisms on Earth. Now, no one is saying this comet carries life itself, but its chemistry suggests something just as fascinating. Researchers say this could be evidence that the ingredients for life weren't unique to our solar system. In fact, they may have been widespread across the early Milky Way. Some scientists suggest that objects like this could have played a role in spreading complex chemistry between star systems over billions of years. It's even been suggested that similar objects may have delivered essential compounds to young planets, potentially helping kickstart prebiotic chemistry. Of course, these ideas are still being explored, and much of it remains speculative. But the implications are hard to ignore. If the basic ingredients for life were already forming this early in the galaxy's history, then the conditions for life itself may have existed far earlier, and in far more places than we ever imagined. And just as scientists are beginning to piece that together, this ancient traveler is already on its way out.
After its brief visit through our cosmic neighborhood, 3I/Atlas is already moving on, heading out of the solar system in the direction of the Gemini constellation. Its departure is as swift and silent as its arrival, leaving astronomers racing to study every last bit of data before it disappears forever. Despite some online speculation and conspiracy theories, there's no evidence that this ancient visitor will return anytime soon, or that it carries any hidden messages. Still, the comet's exit is a reminder of how fleeting these opportunities are. In just a matter of months, this relic from the early Milky Way will be beyond our reach, disappearing into the vast expanse of interstellar space. For scientists, it's a bittersweet moment. We've learned more than ever about a planet-forming system that existed billions of years ago, yet we may never see another object quite like it again. Its fleeting presence underscores the vastness of the galaxy and the rare chance we get to witness such a tangible fragment of cosmic history. And as it drifts away, one question lingers. How many more of these ancient travelers are out there, silently passing through the stars, carrying secrets from a time long before our sun even existed?